Hello, everybody. Today I'll be talking to you about great circle sailing. Having decided what track you want to follow, and as you are going to be doing a long distance, so saving on great circle sailing is considerable. So you decided on going on great circle track. So let us see how we go about solving the problems of great circle. Now we know that the shortest distance between 2 points is a straight line. And what is a straight line basically? A straight line is a line which makes a constant angle with some reference point. And on the surface of the earth, we are measuring all our angles with north. So on surface of the earth, the straight line would be which is making constant angle with north. This line what I have drawn here and I'm pointing towards north. If you notice, all the angles being formed with the north are equal. So this line what I have drawn making a constant angle with north is a straight line on the surface of the earth. In contrast, a curve would make different angles with our reference point north. Now if you see here, the angles with north keep on changing. So this line with angles which keep on changing with north is a curve. If you are viewing the earth from above the north pole, it will appear something like this to you. You'll see the north pole and then all the meridians converging to the pole, because all meridians converge at the pole, and the parallel of latitude, which is a small circle, will be seen something like this. I'm just taking some arbitrary points here. A I have taken as 50 degrees north, parallel of latitude, and 175 degrees, no, 135 degrees west longitude here. Another point B, which is on the parallel latitude of 30 degrees north and 135 degrees east. The shortest distance is a straight line, so I'm drawing a straight line here. But if you look at it here now, all the angles with north, they all different. They're not same. So this, as we just talked about it, a straight line should be having a constant angle with north. So this is not a straight line. So basically, it is not possible to draw a straight line on a surface of the earth. What you are drawing a straight line is actually a curve. And the shortest distance is now on this curve, which is arc of a great circle. And great circle basically is one which has got the maximum possible radius. So the shortest distance what we can cover between 2 points is the arc of a great circle. Though there is an inconvenience in sailing along great circle track, because you'll have to keep on altering your course with each meridian. As you keep on crossing each meridian, you'll have to keep on crossing your course. But the saving in distances, the considerable saving in distances overrides inconvenience caused here. So you follow a great circle track when you are doing long distance sailing to save on time and distances. Now great circle sailing is a solution of a spherical oblique spherical triangle which is formed by the great circle track what you have drawn here. You have decided to sail between 2 points and the meridians which pass through the 2 points which you are sailing. So all the solutions for great circle sailing will involve solving a spherical triangle. So solving of great circle sailing involves solving of oblique spherical triangles. And what is a spherical triangle? These are formed by the intersection of three great circles. Now, in this particular case, when we're talking about great circle, one of the side of the triangle is the great circle track, which we intend to follow between 2 points. Here, these are the 2 points what I've got in the great circle which is passing through it. One side is of the triangle is the side which we intend to follow, and the other two sides are made by the meridians which pass through these 2 points A and B. And then we know the position of our departure, we know the position of our destination, that is our latitude and longitudes. Now, latitudes we know is the arc of the meridian. So, arc of the meridian contained between equator and the place. So, from equator to A is your latitude, and we know that from pole to equator is 90 degrees. So, what is PA? PA is 90 minus latitude, right? Similarly, we know the latitude of B, which is from equator to B. So, PB would be 90 minus latitude of B. And this angle P, what we are seeing here, is the angle between the two meridians which are passing through A and B. So, that is the D long between the two meridians. So, angle P is the D long. So, now we have this spherical triangle in which we know one side here, other side, another angle. And then we can find out what is AB, which is the distance between the 2 points, great circle distance. We can calculate angle A, which we use for finding out what is my initial course. And then I can find out angle B, which is used for finding out the final course. Here I am specifically putting it up here that these are not your courses, these are just angles what you have got after solving a spherical triangle. Now, to find your the questions here in great circle would involve finding the distance, finding initial course, final course, position of vertex, and latitude of some points 10 degrees apart. And here I've just written down 10 degrees west. This will be a full question which is there in great circle solving for great circle sailing. Now, just an example here, what I'm giving you here, that I'm sailing from A to B. The positions are given. I'm going from 10 degrees north to 47 degrees north, 17 degrees west to 89 degrees east. So, my DLAT, I start off with calculating my DLAT. So, my DLAT and D long is north and east. Now, always find out your DLAT and D long because that gives you an indication on how your track is going, which direction you should draw your course on. So, here it is northeast, so I would just draw something like this in the northeast quadrant. Then the next step what I have to do is I use the pole to draw the spherical triangle. I use the pole on the side which has got the higher latitude, and higher latitude here is north. So I will use the pole north, and then I can pass out the meridians through A and B. Now I know the latitude of A, which is 10 degrees. So what remains of PA is 90 minus the latitude. Similarly, on the other side, the latitude is given to me as 47 degrees north. So what remains here on top PB is 90 minus the latitude of B. And as we said that angle P is the D long between the two meridians. So that's my longitude D long here. And now I'm ready with the spherical triangle to solve. Now this solution to this, you could use cos formula. So what you got to find out is AB is your distance. Then you solve for angle A and angle B for finding out your initial cos and final cos. Angle A and angle B is not your cos. How do you name your initial cos and final cos? Which is come up here, initial cos and final cos. You use the name of elevated pole. Elevated pole is the pole what you have used for drawing this figure. And here you have used north pole. So initial cos would be named north. And what is your D long? East. So whatever angle you have got here A, the initial cos would be elevated pole and D long. And in this case, elevated pole is north, D long is east, initial cos would be northeast. The final cos is named opposite the elevated pole. So here I use north, opposite is south, and D long. So this is the easiest way of naming your cos. You will never go wrong as long as you remember this. Now here the example what I'm trying to show you here is again the thing like this. I'm going from south to north, and my D lat and D long I have calculated, which gives me D lat of north and D long east. So I'm going somewhere in the northeast quadrant, and I have drawn it in the northeast quadrant. So the next step that I said was to think about what pole I have got to use. So I should be using the one which has got the highest value. The highest value is south, so I'll use south pole here. South pole. This equator and other things what I'm showing is only for you to understand. Once you have understood what is a PA and PB, you need not draw all this. Just to clarify it for you. Now latitude of A is south, so you're south of the equator. So what is left of PA? We know from pole to equator is 90, so what is left behind is 90 minus the latitude of A. Now for PB, my latitude is north this time, right? 8 degrees north. Now from P to equator is 90, so definitely PB has to be 90 plus. So PB is 90 plus, and angle P is the D long. Now you got to solve for AB, that's your distance. Angle A is your initial cos because you are starting from A, and angle B for finding out your final cos. I have taken the values of 120 is my angle A, angle B is 46 degrees, and the distance here is 3914 what I have calculated, though I have not shown you the calculations here. Now if I had used north pole instead of south pole, as we said, here the cos would be, in this particular case the cos would be south because I am using south pole and east. It will be south 120 degrees east, which is 120 degrees minus 180, 60 degrees, right? And in this case, the course would be opposite, that is north, east, northeast, 46 degrees. So final course would be north 46 degrees east, that is 46 degrees east. In case I have used the North Pole for calculation, now if you see, A is south, so the latitude has gone below, the point A has gone below the equator, so PA would be 90 plus, as we had seen here, and PB would be 90 minus. And the D long will remain the same because these are two meridians, the longitudes are the same, the D long will remain the same. Now these values are supplementary. 180 minus 55 will come up to this. 180 minus 98 comes up to this. They are supplementary sides now, 180 degrees apart. If you solved this triangle using North Pole, your answers would be supplementary to this. That is, angle A would come to 60 and angle B would come close to 134. So these are also supplementary to the angles what we have calculated. So true course basically when we talk about it is measured from north to the ship's head, north to ship's head. The ship is going from here again north to ship's head, and that's why I said it is making an angle of 120 from south. So from north it will be making an angle of 20 degrees. So here when I said it is south 120 degrees east, that means it's 60 degrees true course. And here when I calculated, I have already got the angle as 60. And the pole I had used was north, so northeast. I got the answer northeast here. Similarly for B, the angle what makes with north is 180 degrees minus this value. Yes, and this is what we talked about is the final course. And here also it is the same thing because these two are vertically opposite angles. So you have the final course as opposite of the pole, which was south, and D long was east, so northeast. So you have the same angle here and here. So calculating either way, you are getting the right answers as long as you are able to put the courses, the direction of the courses correctly. But the problem with solving one or the other is this, that when we talk about calculating the vertex, we'll talk about what is vertex. Vertex is actually a point which is closest to the pole. And now if suppose I was talking about calculation of calculating the vertex here, I would be calculating a pole which is point which is closer to North Pole. Whereas here when I'll be calculating a point which is closer to the South Pole. And that is where you might make a mistake. Because you see, I am going up to 34 degrees and 34 degrees, I'm starting from 34 degrees south. And here I am going only up to 8 degrees north. So I'm not bothered how high I am going in the northern latitude. I'm more bothered about how high I am going on the southern latitude. So would be preferable, would be always advisable to use this triangle rather than this. So always remember, they said this is the right diagram. This I consider to be wrong. So always advisable to use the pole to draw a diagram which has got a high latitude. Now this is question number 1 which I am solving it for you. Now this question will come up to you, a great circle question could come up to you to find out the distance, initial course, final course, position of the vertex, and the points every 10 degrees apart from 10 degrees west. So I will take it up step by step here. So I will start off with finding out the distance, initial course and final course today. So I start off with my DLAT and DLong, and I've got my DLAT as north and east. So I am going somewhere northeast. Your DLAT and DLong is an indication which direction you are going to be heading. To draw your diagram, so I've just drawn this diagram northeasterly here in the northeast quadrant. Now here the higher latitude is north, so I will use the higher latitude pole on the higher side, that is north pole. And then I can draw meridians through A and B, and now I have the spherical triangle what I have to solve. Now the only thing is I have to find out what is what. So what is PA? I know that the latitude of A is 10 degrees south. That means A is 10 degrees south of the equator. So my PA would be 90 plus. As you can see, I am crossing the equator. From pole to equator is 90 plus. I got my PA there. Similarly, for PB, I'm on the northern latitude. Now my PB would be 90 minus. And angle P is the D long. And I'm ready with the spherical triangle to solve for AB, angle A and angle B. Now these can be solved using cos formula, Haversine formula. I've written down azimuth table here, ABC tables, what we call them, which involves again the formulas of tan for A and tan for B and other things. Today I'm just going to be talking about cos formula only. Maybe in some other class I'll talk about Haversine and as ABC tables. And I'm not very sure about the ABC tables, use of ABC tables for the examination part of it, but I'll give you a idea how to use the tables or how to go about calculating with ABC tables. Definitely I'll come back to Haversine because Haversine is a formula which would be more suitable for most of the things. But today we'll talk about cos because nowadays with you fellows having your calculators in front of you, normally you won't go in to look into the tables, and even Haversine you could calculate with cos formula. But today I'll restrict myself only to cos formula here. And I believe that you should not mug up anything, you see. So I'm just trying to make you understand, and once it is there in your mind, I think you'll never forget it. In cos formula, you start off with an angle, whichever angle you want to start off. So I'm starting off with angle A here. So I write down cos of this angle here, and then the next thing I write down what is opposite cos of what is opposite angle A, which is side PB. So I write down cos of that, cos of the side which is opposite A. Now what is remaining is this and this, that is PA and AB. So I write down next minus cos of the other two sides which are remaining here, that is PA and PB. And then I divide the whole thing with sine of these two sides, the other sides. Very simple to remember. I'm repeating it for other two angles also so that it is clear in your mind. You don't have to mug it up as long as you can get it into your head. So let's talk about next angle here, angle P. Now when I'm talking about angle P, the side opposite is AB. I will write down next side would be cos of AB. And then what is remaining? This side and this side. I write down minus cos of the other two sides. And divide it by the sine of these two sides, PA and PB. Similarly, suppose we talked about angle B, side opposite, the remaining two sides and divided by sine of the remaining sides. Simple to remember, easy to use with your calculators. So now this just give you an idea about how to go about naming your course once again before we get down to solving the thing. Now to name the course A to B, that's your A to B. If you're going A to B, this is your initial course. To draw, use the pole which is higher value, south. Initial course would be south pole and the D long. It will become southeast. And the final course is opposite the elevated pole and D long. Elevated pole north, the south. So opposite is north, D long is east, northeast. Or if you can understand this part of it, always place your ship's head on the point where you are starting from. I put my ship's head here. Now the course is always measured from north. What is the angle it is making from north? This line is 180. From pole to pole, 0 to 180. It is making an angle of 60 degrees. So initial course would be 060. Now another one property of spherical triangle that they are also having the vertically opposite angles are the same. So the angle what is formed here with the north pole B and the ship's head would be the same as 46 degrees here, and that would be the angle what we are making with north. So my final course would be north 46 degrees east. Now the same position, but I'm just changing the direction. I'm instead of going from A to B, I'm coming from B to A. Values will be the same. So my D lat and D long is going to just change from north to south and east to west. So I'll be going something like this. Now if I put the southwest, what I got the D lat and D long, I place the ship's head here where I started off from. What is the angle I'm making with the north? 180 plus 46. Isn't it? That's the head. That's the angle what I'm making with north. So initial course would become 180 plus 46. And similarly for here, when I'm coming to my final course here, this was vertically opposite angle. This is 120. So from north, I'm making an angle of 120. So it will become 360 degrees minus 120. So initial course has become 180 plus, and the final course is 360 minus 120, 240. I would rather always, I mean, if this is also clear to you is good enough, but remember if you can put it just with the right pole there and remember it, initial course is elevated pole and D long, final course is opposite elevated pole, you'll never make a mistake. Now this is a question what is given to you, I'm solving it to you, solving it for you, just to show what is the steps, how you go about doing it. Though my calculations are not fully shown here, so I'll expect you to show all the calculations with all the values, whatever is required. So do not just follow my calculation. This is only for your understanding part of it. So I start off with angle P, cos P, side opposite AB, other two sides what are remaining, cos of that, and sine of the same two sides here. So here I am finding out AB. I have cross multiplied, transported it this side and got this value here. Put the values. As I said, I'm not showing you all the steps, all the values here. I have not put the values here. You go ahead and show them, and you get AB as the distance AB. Here again I said please show full calculations. Now for initial course, I'm going to find out angle A. What is opposite angle A? PB. What are the two sides what are left? PA and AB. PA and AB. And sine of this. Put the values and you get the answer. Angle A is 43 degrees. 15 minutes here. And how to name it? The pole, elevated pole, north, and D long, east. So your initial course would be northeast. Initial course is northeast. Now the next step is to find out angle B for finding out your final course. Opposite B, PA. Other two sides remaining, PB and AB, and sine of them. Put the values. Angle B. Now angle B is 84 degrees. As I said, change the name of the pole what you have used for drawing, make it opposite. You use north, it becomes south, and the D long is east. So your final course is southeast 84 12. Now if you just visualize putting up your ship head here, with the ship's head it will make angle of 43 degrees. When you are crossing this here with ship's head, this is 84 degrees, this is vertically opposite angle here. So it will be making an angle of 180 degrees minus 84 degrees, which will amount to the same value here. So up to you how you want to do it. I find this is an easier way to do it. Now I have got what I have calculated here. I have calculated the distance, I have calculated angle A and angle B, and of course converted them into initial course and final course. So I have taken care of the first three things here: distance, initial course, and final course. Thank you. I will continue with vertex in the next lecture with you. Till then, have a good day.